Hi, thanks for joining. My name's Graham Charters. I'm an IBM Senior Technical Staff Member and I'm the Technical Product Manager responsible for traditional WebSphere, WebSphere Liberty and Open Liberty. So essentially the IBM application server runtimes. And the talk I've got today is all about reducing costs and increasing agility in hybrid cloud and how Liberty helps you do that or enables you to do that. So I'll start with talking a little bit about sort of industry context. So a bit about the directions we see enterprises going in terms of digital transformation, some of the challenges they have today, and how we're looking to address those challenges. And then I'll talk about Liberty and how Liberty is helping enterprises address those challenges, reduce their costs, and also increase their agility. And that'll be about the first 10 minutes of the session, and then the following 20 minutes will be a demo. Now, I usually do these things live. I was actually told that the platform didn't support doing screen sharing, so I recorded a video, and then I was told the platform did support screen sharing. However, I'm going to use the video. There are a number of benefits. I've just been on a session where my screen wouldn't share, so that's one benefit. We know it's going to work. The other benefit is I'll be able to answer questions in the Q&A whilst the video is going. So you can ask questions throughout the session, and please do, and I'll get to answering them probably about 10 minutes into the session, and I'll start responding in the Q&A at that point. Okay, so let's get going. So digital transformation is nothing new. It's been going on for many, many years, but I think it's quite clear that unfortunately the pandemic has led to a need for enterprises to accelerate their digital transformation activities. And in fact, the McKinsey survey data that we have basically shows that enterprises have gone through what is effectively 10 years of digital transformation in the past year, or in under 1 year. The other thing it's done, so previously customers or enterprises were going through modernization and digital transformation exercises, because those were going to help them continue to be competitive and continue and compete with the kind of new modern born on the cloud competitors. However, with the pandemic and with lockdowns and so on, almost become essential for many enterprises to have a very strong, good digital presence and a very strong online presence, and essentially move the vast majority of their business to be online. And that's kind of shone a spotlight on their application portfolio, on their applications, and whether they were really ready. And in fact, the vast majority of enterprises don't believe they were ready to be able to support those kinds of uses and workloads. And when we talk to our customers, and what we hear from enterprises in general, not just WebSphere customers, there are a number of challenges, and these are, some of them are unique sometimes, or not specific to WebSphere, and a lot of them are actually shared with our WebSphere customers. So invariably, we always hear about time to market challenges, the ability to deliver new capabilities rapidly. And this is why enterprises are trying to become more agile and become more agile in their IT and in terms of their delivery, and being enabled to be more agile through the use of cloud and cloud native. High operational costs are always a challenge. We're always being asked to do more with less, and managing complexity. So a lot of enterprises have been running their IT systems for many, many years. WebSphere application server itself is going to be 25 years old this year. And we have a lot of customers that have very complex WebSphere estates. They have multiple versions of WebSphere running concurrently. And of course, as a result, that can be a costly operational exercise, and they are looking to reduce their costs. Another big challenge is the lack of cloud skills and cloud technology experience. So this essentially means I talk to WebSphere operators on a regular basis, and they've been managing WebSphere environments for 10, 15 years, and they've built up skills and assets in that space, and now they're being asked to essentially do the equivalent in a more agile way in a cloud environment using things like containers and Kubernetes. So there's a big skills gap there that we need to be able to plug. So I'm going to also talk a little bit about some of the things we've done with WebSphere and Liberty to enable plugging those gaps. And then, of course, there's the ever-present technical debt challenge, and technical debt exists for many reasons. Often it's because of time pressures, and often it's because of friction in terms of trying to do the right thing. So, for example, when customers try to move their application server environments up to the latest level, if that's a costly exercise, and in fact, with most runtimes, or in fact every runtime I know apart from Liberty, that is a very costly exercise to do because there are breaking changes and things that you have to deal with. Then, then people are reluctant to do that, and that means they build up technical debt and they potentially build up security vulnerabilities because they're not on the latest levels. They've not got the latest security fixes. So let's see a little bit about why WebSphere Liberty, and essentially why Liberty helps with these challenges. So to help us articulate and I guess quantify some of the benefits of Liberty in an independent way, one of the things we did is we commissioned Forrester to do a study. So this is an independent study. We obviously fund Forrester to do the work. We identify or help put them in touch with customers, but at that point we're not really involved. They go and they interview the customers, and they do their calculations and create the study, and we can provide feedback. But ultimately, it's Forrester's word that goes out there. And so we did this around Liberty. We identified 4 customers for Forrester to interview, who were traditional WebSphere customers that moved to WebSphere Liberty. They did the interviews. They created what they call a composite customer and did their calculations. And what they found was that on average, those customers achieved a 50% increase in developer activity. They achieved a 40% increase in IT admin productivity. And one of the things we hear about modernization, so these are essentially benefits. If you think about your existing customers today, or the existing work that you do today around WebSphere in terms of development and operations, and then imagine you can actually do the development with in half the time, or with half the cost, and you can do the operational side of things 40% cheaper. Those are significant cost savings, or potentially significant agility improvements that you can achieve. But in order to get there, there's some work to do. And one of the things we often hear is that there's pressure to rewrite rather than reuse your code. It's always going to be more costly, or vast majority of times it's going to be more costly to do a rewrite. It's also potentially more risky because you're essentially rewriting that application that you know has been working for many, many years. The logic is right. It does what it needs to do. And so what we do is we've done a lot of work to make it very, very easy to get to Liberty. And in this study, they found that when customers moved from traditional WebSphere to Liberty, they got payback within 8 months, and they actually achieved 195% return on investment. And this is because we've done a lot of work to kind of simplify that exercise. So there are a number of things that we've done that reduce the developer costs, reduce the operational costs, and improve or simplify the modernization. So on the developer side, we've done a lot to kind of streamline the developer experience, and we'll see some of that in the demo. We've modernized, if you like, how we released software. So we've been doing agile development and delivery in the WebSphere organization for many years around Liberty. We optimize how we deliver containers. So we release Liberty every 4 weeks. And it's a full release that you can pick up. It has all the latest security fixes, all the latest performance enhancements, all the latest features, and so on. But we don't. What we don't do is introduce migrations as part of that exercise. So we have this zero migration architecture that means if you have an application that runs on Liberty today and you want to run it on the next version and the next and the next, you don't have to change the application code. You don't have to change the server configuration. So we essentially remove that friction I talked about. We make it very simple to move to the latest level, get the latest security fixes, and so on. And that's all available through the Liberty releases, but also the containers that we release as part of those releases. On the operational side, I talked about the skills gap. One of the things we've done is we provide a full level 5 capable Kubernetes operator for Liberty that greatly simplifies the deployment and management of applications running on Liberty in a Kubernetes and container environment. So this helps reduce that skills gap. It also helps reduce because it reduces the complexity, it reduces the risk of introducing problems through your deployments. The other thing we do is we auto-tune the runtime, so you don't have to go through those costly tuning exercises. And particularly if you're deploying in cloud environments, you don't necessarily know what the environment's going to look like when you do that tuning. On the modernization side, as I said, we do a great deal of work to enable a number of the APIs that are used in existing applications to also work on Liberty, as well as configuration that also work, as well as traditional WebSphere configuration also being mappable easily to the Liberty environment. And we provide tools to help you do those migrations in the form of Transformation Advisor, WebSphere Application Migration Toolkit, and Mono to Micro. So what I want to do is we're going to see a demo, as I said, and I'll be answering questions in the Q&A whilst that demo video is going. The demo is going to illustrate some of the capabilities or some of the things that I talked about. So there are 4 parts to it. The first is I'm going to create a new microservice using the Liberty Starter. The second step is I'm going to show how easy it is to develop that code and evolve that code rapidly in an IDE. So using Visual Studio Code and something called dev mode to do rapid iterative development. And they're going to show how easy it is to build a container, a production-ready container that fits exactly the needs of the application. And then lastly, it'll show how to deploy that container, that application in the container to the Azure Kubernetes service. So essentially to the Azure cloud. So if we can start the video now. Okay, so what we're going to see is the rapid iterative developer experience that's provided by Liberty. And the first place we're going to start is with creating a new project. And the best way to do that is using the starter. So we're going to go to start.openliberty.io or openliberty.io/start. And this gives you the starter, which is a web page that will generate you your new project. You can specify what you want the group ID and artifact ID for the project to be, and here we're just going to call it, and if I could type, Liberty Cloud Demo. You can choose the build tool you want to use, Maven or Gradle, and I have more experience with Maven, so I'm going to stick with that. You can choose the Java SE level. These are the current LTS levels that are supported by Liberty, and we aim to support all in support levels of Java SE based on community support timelines. So I'm going to stick with the default Java 11. You can choose your Jakarta or Java E level, and Liberty uniquely supports multiple levels because of its zero migration policy or zero migration architecture, which means your applications can remain on an older level of the APIs if they want. You're not forced to move up to get the latest security fixes and performance enhancements. You get those essentially for free as you continue to move up the levels of Liberty without having to change your application code. And you can choose the level of microprofile. So I'm going to choose the defaults for these. These are the latest levels that support the new Jakarta namespace. And I'm going to generate my project. And let's have a look at that in the Finder. I'll just unzip that project and then we can open it up in a terminal. So we can see what I've got is a Docker file for building a containerized application. So this is a microservice application I'm going to develop. We've got the Maven wrapper for doing the build of the project. We've got the POM XML, which is essentially the instructions for that build. And we've got the source directory, which contains the source code for my application or the starter source code for my application and the Liberty server configuration. Okay, so we've got our new project which we generated using the Liberty Starter at start.openliberty.io. And now what we want to do is use the rapid iterative developer experience that's given to you through tools integration and the Liberty Dev Mode capability. Liberty Dev Mode works with Maven and Gradle, so is independent of any IDE or text editor. You can use it with any of those. But we also have specific integration with certain IDEs, and what I'm going to demonstrate here is the integration with Visual Studio Code. So I'm going to fire up Visual Studio Code for the project, And so this is the project that was generated for me. And we can see that we have in the source directory, we have the starter REST application. There's no resources defined because we don't want you to have to go through and delete code that you don't particularly need. And then there's the server configuration that we generated. And because I chose Jakarta 9.1 and MicroProfile 5, those features are configured into the server. But actually, for my particular application, I don't want to use, because I'm just doing a REST service, I don't need all of those capabilities. So that's just going to be additional bloat for my application. So what I'm going to do is I'm going to get rid of these features and actually just use the REST capabilities. So RESTful Web Services 3.0, and I'm going to save that, and let's start the server up. So this will start the server in dev mode. Okay, so here we can see the server starting up, and initially I didn't have anything installed, no Liberty server installed or anything. I just had the Maven POM, and what the builder's done is it's pulled down the Liberty kernel, and then it's pulling down and installing the individual features required for my particular server configuration. So we saw that it pulled down the RESTful Web Services feature, for example. And I can hit that endpoint, and there's nothing there because we don't have any resources defined. Now, what I also want to do, because I'm developing a REST API, I want to use the Open API capabilities and the Swagger UI that comes with that to see the APIs that I'm generating and try them out. So I'm going to add in a couple of features. I'm going to add in MicroProfile Open API 3.0, and because I'm using JSONB as part of my REST service, I'm going to add that feature in as well. Okay, so let's save that server configuration, and we can see that the server has automatically detected that the configuration has changed, and it's now going to install those additional features. And it will pull those down again from Maven Central, but it can pull them down from any Maven repository that you've got configured. And here we go, we're now updated, and I can now hit the Open API endpoint, and we can see that I now have the Swagger UI available, but there's no resources defined. So what I'm going to do now is show the kind of iterative developer experience. So I want to add a REST resource. So let's create that new Java file. And I'm going to cheat a little bit, so I'm going to reuse some code I already have. This actually comes from the Open Liberty guides, and it's just a REST resource which will return the system properties for my particular laptop. So I'll save those changes. They've automatically been detected and immediately reflected. So now when I refresh the Swagger UI, we can see we've now got a resource, and I can try that out. Make calls to it, and you can see these are the system properties for my particular server, or I should say for my laptop. Okay, so that's the rapid iterative developer experience. You can see how you can add and remove features from server configuration dynamically, and it automatically pulls them down as and when needed from a Maven repository. And you can see how you can dynamically make changes to your application and server configuration and have those immediately reflected in the running server. So there's no need to do a rebuild or a redeploy as part of your developer experience. Okay, so we've developed our new cloud native microservice using VS Code in this example and the dev mode capability, so we can rapidly iterate on the code. But we're at the point now where we want to develop packaging that up into a container for production deployment into a Kubernetes environment. Now, building the container will be typically done as part of some pipeline, but in this example, what I'm going to do is just essentially developing the Docker file and want to give it a try and so on. And so I'm going to show how easy it is to do that. So let's just stop our server and take a look at the Docker file. So this is the Docker file that was generated from the Liberty starter, and we can see it's being based off a an image that's in the IBM container registry, because the IBM container registry doesn't have rate limiting, whereas Docker Hub does, which can be a bit problematic. And we're going to base off the kernel image, and we're using Java 11, the OpenJ9 JVM, which is much more efficient than Hotspot, and UBI as the underlying OS image. The first thing we're going to do is we're going to copy the server configuration over from the source directory of my project into the config directory in the container image. And we're going to run this features command. This features command essentially, because we've only frommed the kernel image, this is going to then add the features that are required for my particular application. So I'm essentially building a container that's specific to my application's needs. So there's no bloat in there, no excess baggage. And then I'm going to copy across the application in the form of a WAR file. And lastly, I'm going to run this configure script. And this configure script, what that does is it essentially primes the container. It starts up the server, stops the server, so that caches get set up, class caches, so that ultimately when you come to deploy this into production, it will start really, really quickly. Okay, so, but the first thing I need to do is, if I look in the target directory, there's no WAR file there. So because I've been using dev mode doesn't build a WAR file. It essentially assembles up the files on the file system into a kind of logical application that's running in the server. So we need to build that WAR file. So we're going to use the maven package command to do that. And then we have, if we look in the target directory, we can see there's now a WAR file. And next I'm going to build this container. And I'm going to use the doc file, so just the one that's in this local directory. And so that's going to go through the steps, the features. So it's already copied across the files. It's now running the features command, which will install just the features I need. So in this case, the server has REST. It has the JSONB feature, and it also has the OpenAPI feature, so that we can take a look at the Swagger UI. The time this takes kind of depends on what builds you've done before. I'm starting fresh, so I've not got anything cached, so this will take a little while. And it also depends on what features you've got configured into the server. So the smaller the number of features, the fewer features it has to pull down and install. Okay, it's now running the configure script, which, as I said, is going to start and stop the server a couple of times, so that when you come to deploy this into production, your server's going to start really fast. So the nice thing about this is you're paying the price during the kind of build, which would be in some pipeline on some build server, and only takes a little while to do this, which means that when you come to deploy into production, if you're scaling up and down, you're going to get fast starts for your new instances as and when they're required. Okay, so I've built my container image. So now what I can do is I can try that image out. So let's run that image. Oops. So we're starting the server up, and it's now up and running. And what I can do is I can go to my browser and go to and here's my endpoint, and I can try that out. And these are essentially the system properties for my container image. Okay, so we've created our container and we've tested it out. And what we want to do now is deploy that to a Kubernetes environment. And what I'm going to do in this demo is use the Azure Kubernetes service in the Microsoft Azure cloud. And so to do that, I need to first stand up an instance. And what we've done is we've worked with Microsoft on producing a number of offers for the WebSphere portfolio. We have essentially the ones on this top row, which are, say, by IBM WebSphere, are the ones that we provided. So we have offers for traditional WebSphere. So the first one is an ND cluster. The second one is a single server instance using the base edition. This is just an overview offer for all of the offers. And then the next two are Liberty offers. The first one is WebSphere Liberty and Open Liberty on the Azure Kubernetes service. And the second one is WebSphere Liberty and OpenLiberty on Azure Red Hat OpenShift. So we're going to use the first one. And so you can click on it, review the information about it, read more about it, and then choose to get it now, which will direct me to the page to then create an instance. And I'm already logged in. You may need to log in order to do this. And so what I'm going to do is again, you can read the details, but I'm going to create an instance. This gives you a form to fill out, so you can define the resource group that's going to contain the things that you're creating as part of this deployment. So in this instance, you get an Azure container registry and an Azure Kubernetes service instance. You need to specify user assigned managed identity. You can create one at this point or assign an existing one. You can configure the cluster, so minimum number of nodes, maximum number of nodes, and so on. Or you can choose to reuse an existing cluster. And here's where you can choose to use an existing Azure container registry or specify a new one. And then you can optionally provide an application. So this would point to a container that contains an image, or we can use actually a sample container that's already been pre-built if you want to just try things out. Okay, but I've already created an instance because this takes about 20 or 30 minutes. So this is the instance I've already got, and you can see it's got an instance of an Azure container registry, and it's also got the Azure Kubernetes service instance. One of the nice things is if you take a look at the deployment, and we click on this part of the deployment, which is the one that took the longest, we can see in the outputs there are lots of useful commands that we write out as part of that deployment. So information about what the cluster is, the container registry name, but also useful commands for logging into the container registry, connecting to the cluster, so you can do deployments, how to tag an image, push an image to the Azure container registry, and so on. And this last one, this is actually a base64 encoded example YAML for doing a deployment using the Liberty operator, which has already been pre-installed. It's base64 encoded, unfortunately, because of a UI limitation in the Azure cloud. So now we're going to do our deployment to this Azure Kubernetes service instance. And first thing I'm going to do is I'm going to just set a few environment variables. It just means I can use exactly the same commands depending on for different clusters. So I'm going to set a value for the cluster name, the container registry name, and the cluster resource group name. And the first thing I need to do is log in to the Azure cloud. Okay, and we'll just wait for that login to finish. And then the next thing I need to do is log into the Azure cluster, and you can see I'm using those environment variables as part of this, but the exact commands to do this are actually provided in that output that I showed earlier. And I'm going to log into the Azure container registry so that I can push my image to that registry. Okay, and the next thing is I now want to tag the image. So if we look at the images we've got, we can see I've got the one I built, which is tagged as latest, but I want to tag this with a version and also for the particular registry where I'm going to deploy it. So now if we look, we can see I've now tagged it for that Azure Container Registry instance with a version of 1.0. And now what I need to do is then push that up to the container registry. And we can see from these commands, this is why I did the Azure login, because then we can use these Azure commands. What we can do is actually look in the Azure Container Registry and have a look at, just to check that that's been pushed. So if we go to our deployment and go to our Container Registry instance, and then we go to repositories, we can see here's the Liberty Cloud demo, and it was pushed up just a little while ago. So now we've got the image in the container registry, we need the configuration for the actual deployment. And as I mentioned, the base64 encoded information in that output, you can decode that to give you an example YAML for deploying the application or deploying an application to that cluster using the OpenLiberty operator. So I've already decoded that, and what I'm going to do is create a new file for my deployment. And I've modified it slightly because I want to again kind of templatize it just for ease of demo purposes really. So this ACR name is something I'm going to replace as part of doing my deployment. Okay, so that's my YAML. What this is saying is it's going to use the OpenLiberty operator, and that's looking for a kind of OpenLiberty application. We're just calling it Liberty Cloud Demo. I want 2 replicas. The image name is the one I've pushed up, and I'm going to substitute this with the Azure Container Registry name. I always want to pull updates, and we're going to set up a load balancer across 9080, and that's the port that the instances are going to be listening on. So this slightly convoluted sed command, I wouldn't have to do this if I hadn't templatized it. I would just do kubectl apply and the file name. But as I said, I'm going to replace the ACR name value in that YAML with the environment variable I set up earlier. Okay, so that starts the deployment, and we can look to see how it's getting on. Okay, they're already running, so that's good. We can see that I actually stood the instance up a couple of days ago, actually nearly 3 days ago, because that's when the OpenLiberty operator was installed. Okay, next thing we're going to do, we're going to get the service. So I mentioned that I'd set up the HTTP endpoint as part of that cluster deployment. So now I can get the service, and from that I can see where it's exposed. So the external IP is this. So if I now go to that location on port 9080, and we can see I've got the Swagger UI, and I can try that out. And there we go. We're getting the system properties for my container running in the Azure Kubernetes service. Okay, so hopefully you found that demo useful. We essentially went from no server installed, no application code. So starting using the starter to create the application code, showed the developer experience in Visual Studio Code using Liberty Dev Mode, showed how easy it is to build a container that fits exactly the needs of the application, and to optimize that container for production. And then lastly showed deployment using the Liberty operator to deploy to a Kubernetes environment. And in this case, it was the Azure, a cluster in the Azure Kubernetes service. So last up, I just want to share, sorry, I was looking in the Q&A, I see a question appeared, but I think it's just someone asking about sharing the slides. I think the session will be recorded, so we'll be able to share the recording for you to view later or share with other people. So just last up, a few hopefully useful links. So I mentioned about the TEI study. So there's a link to the TEI study, so you can read more of the details about how that study was performed and some of the quotes from the customers and some additional metrics in there around the benefits of moving to Liberty. Feel free to join the WebSphere user group community. We advertise sessions there. There are blog posts that get put up on the community. You can also ask questions on the community if you want to find out more information. And lastly, we've got the link to the WebSphere Liberty website. Also, if you want to try Liberty out, I haven't got a link on here, but if you go to openliberty.io, which was essentially where the starter was, there's lots of great information there, and also a lot of guides, hands-on guides that you can try. Okay, so with that, thank you very much for listening. I really appreciate you sparing the time. Thank you.